The lymphatic system has become appreciated as being important in brain functions, but most of the attention has been focused at diseases such as Alzheimer's, where it's known believed to be a buildup of toxic materials. And so the lymphatic system being like a garbage collection system, removing those toxic materials such as amyloid beta proteins. For migraine, it has now begun a focus of attention, including in my lab, asking, could this function of the lymphatic system also be contributing to migraine? And specifically, we're thinking about inflammatory compounds, and diving down even deeper, my question was with CGRP. CGRP is a neuropeptide that we recognize is important in migraine. There's now 8 FDA-approved drugs that are targeting CGRP or its receptor that are effective as preventatives and for acute treatment. So could this be a collision of two worlds, the CGRP world and the lymphatic world? And that's what Jeff Aleph and I started tackling. And with mice, we came up with some, I think, pretty good evidence that CGRP is decreasing lymphatic flow. And this is in mice, not people, but mice. But I'd emphasize that CGRP causes migraine when injected into people in the same manner as we inject CGRP in the mice. So I think it's very likely that CGRP could be causing migraine in people by decreasing lymphatic flow. That was in one major take home. That was a long answer on that. But the second half of the story that I talked about is even more exciting. Unless you're a CGRP person like me, I'll think CGRP is exciting to me. But the second part of the story is we found that we could actually treat this action of CGRP by giving the mice Prazosin. Prazosin is a drug that was developed way back in the 1970s, 50 years ago, for treating hypertension. It's relatively safe. It's still being taken by hundreds of thousands of people every year. There's a couple million prescriptions a year in the US alone for Prazosin, not so much for hypertension, but for, and this is why we started looking at it, PTSD and insomnia and nightmares following post-traumatic stress disorder. So we're looking at migraine and post-traumatic headache in my lab. So I thought, well, Prazosin, let's use that, because a cocktail of drugs that included Prazosin was shown by Macon Nettergaard over a decade ago to improve lymphatic flow in awake animals. So we thought maybe since Prazosin could improve lymphatic flow in general, maybe it could compensate for what CGRP is doing. And indeed, we found that's the case. So we're super excited by this because not only have we found a mechanism we think could be important for how CGRP contributes to migraine and post-traumatic headache, but also we think we found a way that you can alleviate that problem of headache caused by CGRP. So the last thing I'll throw in, so now we have the two worlds colliding, CGRP and lymphatics. I think it's more than that. I think we have two other worlds coming in, and that's the vascular system and the lymphatic system. So work that's been known for, my goodness, 30 or 40 years. CGRP is the most potent vasodilator of all the peptides. So we have vasodilation by CGRP. CGRP coming in, decreasing lymphatic flow. And the third arm coming in is the lymphatic system. Kathleen Corona has shown that CGRP reduces lymphatic flow. So the central node of all these actions, vascular, lymphatic, is CGRP. I think that the fact that CGRP is at the intersection of these three systems could explain why it's such a good migraine target, and may explain some of the biology of migraine.